In the vast expanse of the night sky, where stars twinkle like scattered diamonds, there lies a secret veiled in the darkness, a secret that will set the heavens ablaze and leave the world awestruck. Amidst the countless stars that dot the cosmic canvas, Betelgeuse, a crimson giant in the constellation Orion, harbors a revelation that defies imagination. Behold, for Betelgeuse is not merely a celestial speck, but a harbinger of a cataclysmic event so profound, it will shake the very fabric of existence. Concealed within its fiery depths, this colossal star teeters on the brink of an unfathomable transformation, an event so magnificent, it promises to rival the luminance of the moon itself. Picture, if you dare, a spectacle so grand that its brilliance pierces the azure veil of day, casting its radiant glow upon a world ensnared in wonder. Betelgeuse, nearing the culmination of its cosmic odyssey, prepares to unleash its final act, a supernova eruption of such magnitude that it will illuminate the cosmos with an intensity previously reserved for the realm of dreams. Scientists have been keeping an eye on Betelgeuse for years, noticing its strange changes in brightness with a mix of wonder and excitement. Unlike most stellar events, Betelgeuse's upcoming supernova isn't just another faraway cosmic event. It's a show that everyone on Earth could see, giving us a rare, unfiltered look into how stars die. The explosion is expected to send out a wave of light and energy that will show how powerful the universe really is and give us new information about how stars die. Not only its size or the fact that it could be a sight to see, but also how close it is to Earth makes Betelgeuse stand out. Since it is only 600 light-years away, its supernova would be visible to the human eye and could be the subject of many scientific studies that could change the way we think about how stars evolve. Scientists think that this event could give us very useful information about how supernovas help fill the world with heavy elements that are needed for life. Over 400 years have passed since the last time people saw a supernova with their own eyes. The last part of Betelgeuse gives us a front-row seat to a cosmic show that has been going on for hundreds of years. This event, which combines beauty and science, is a sign of things to come and will make us think about the world and our place in it. As we approach this important cosmic event, people around the world watch and wait. The supernova at Betelgeuse is both an end and a beginning. It shows how the universe works in a cycle, with endings leading to new starts. The explosion will be a sharp reminder of how big the universe is and how beautiful the celestial bodies that live in it are, only for a short time. Continuing from the fascinating idea of Betelgeuse's supernova as a cosmic show, such an event has huge stakes, both because it will be so visible and because it will yield so much scientific information. The bright flash and glow of Betelgeuse's last days would be safe to see from Earth, but the event has a much bigger effect than just being beautiful to look at. The explosion of this huge star provides astrophysicists with a unique real-time laboratory and may change the way we think about the universe. The energy from Betelgeuse's supernova, which includes neutrinos and electromagnetic waves, from the very small to the very large, would flood our solar system. This would be a once-in-a-lifetime chance to study these events as they happen. Gamma-ray bursts are guided emissions from some cosmic events that can be dangerous. However, the radiation from Betelgeuse should be safe because it is a supernova and is pointing away from Earth. This harmless shower of cosmic particles might help us improve our models of how stars evolve, especially those that show how huge stars end their lives and how they fall apart. In addition, the explosion might shed light on how massive stars add heavy elements to the universe. Compounds like carbon, oxygen, and iron are made in the centers of stars and then spread out into space by these explosions. Scientists would be able to see this process directly during Betelgeuse's supernova. This would help us learn more about how the universe's complicated chemistry changes over time, impacting everything from the creation of new stars and planets to the very chance of life. The event would also be a test run for our networks for watching the sky and our early warning systems for cosmic events, including those that could be dangerous to Earth. We would have to see how well we can handle and study a huge amount of data in a lot of different wavelengths and particles. This could lead to improvements in observational technologies and methods. The event that followed Betelgeuse's supernova would also help us understand how supernova remnants work, including the spreading shockwaves and matter that are thrown into space. By studying these leftovers, we can learn more about the interstellar medium and how explosions like these affect the structure and development of galaxies. Betelgeuse's supernova doesn't directly threaten Earth, but it will have a huge effect on what scientists know and how they understand it. This event could be the foundation, a lighthouse in the dark, that guides our search for answers to the most mysterious things happening in the world. So Betelgeuse's last act is not only proof of the circle of star life, but also a key to finding out more about the universe. After talking about how interesting it is that Betelgeuse is about to go supernova and what that means for Earth and science research, let's look at what makes Betelgeuse different from our own star, the Sun. This exploration is based on a lot of science facts and is meant to show the differences and unique features that make Betelgeuse so interesting and studied. It is a red supergiant star in the constellation Orion. When put next to our Sun, Betelgeuse looks like a huge mountain. Its width is about 1,400 times that of the Sun. This means that if we put Betelgeuse in the middle of our solar system, it would swallow up the inner planets and reach past Mars, maybe even to Jupiter. Because it is so huge, it is called a supergiant, which is a stage that stars with a lot of mass reach near the end of their lives. Even though Betelgeuse is very big, its mass is not as disproportionately big as its size would suggest. It is thought that Betelgeuse has 10 to 20 times the mass of the Sun. The difference between the star size and mass shows that supergiant stars are less dense and more spread out than smaller stars like our Sun. The temperature of Betelgeuse's surface tells us another story of difference. The surface of the Sun is always 5,500 degrees Celsius hot, but the surface of Betelgeuse is always around 3,500 degrees Celsius cool. This cooler temperature helps give it its red color, which makes it different from the Sun's bright yellow color. The different temperatures also show that they are at different points in their lives. One of the most interesting things about Betelgeuse is how it changes over time. Unlike our Sun, which stays pretty bright most of the time, Betelgeuse is known to go through big cycles of getting darker and brighter. Astronomers are confused by these changes, which is why they are keeping a close eye on them. The star dims every so often. This is because its upper layers are changing, and gas and dust are being thrown off, which can block its light. This kind of activity is normal for red supergiants, but it gives us a unique chance to see these processes happen in real time. Also, Betelgeuse's end as a supernova is very different from what scientists think will happen to the Sun. Betelgeuse is going to explode in a supernova, which will light up the sky. On the other hand, the Sun will change into a white dwarf much more slowly after becoming a red giant and losing its upper layers. We need the power of advanced computer models to peel back the layers of this cosmic mystery as we learn more about Betelgeuse and the interesting predictions about its future. For example, scientists use complicated computer models to figure out how stars like Betelgeuse behave, especially how they change before and after a supernova explosion. These simulations are very important because they let us see things that even the most powerful telescopes can't see. Astronomers use the rules of science to make detailed models of stars that include things like mass, temperature, brightness, and composition. Simulations help figure out when and how to see Betelgeuse's supernova. Even though the star is very mysterious, changes to the model parameters let experts see how small changes can have big effects on the results. Based on these computer tests, Betelgeuse's supernova might be one of the most amazing things to see in the night sky in thousands of years, brighter than the moon and visible during the day. Simulations of Betelgeuse's supernova also help us understand what happens after such an event. They look into how the explosion would spread elements that are needed for life throughout the galaxy, adding to the cycle of matter in the universe. This knowledge is very important for understanding how supernovas create the building blocks for stars and planets to come. The pictures that come from these models are not only used for science, but they are also beautiful works of art that people love. Computer models have never been more important in astronomy than they are right now as we get ready to see one of the most important events in the history of the field. They not only help us understand stars like Betelgeuse better, but they also get us ready for what we might see, so we can enjoy and learn from every moment of this show in the sky. You might have thought that Betelgeuse couldn't get any more interesting, but new findings have shocked scientists. What did the James Webb Space Telescope find out about this cosmic time bomb that is ticking? Stay tuned as we delve deeper into the mystery and look at how cutting-edge technology and the smart people who work on it have led to new finds and insights. Following the thread of anticipation created by the possibility of Betelgeuse's supernova and strengthened by our exploration through simulations, recent observational campaigns led by the James Webb Space Telescope have shed new light on this huge star's current state and its ultimate fate. Thanks to its high precision and sensitivity, especially in the infrared range, Webb has given astrophysicists a better-than-ever picture of Betelgeuse's surface and its surroundings. The detailed pictures of Betelgeuse's surface taken by Webb have been one of the most important discoveries. They show huge convective bands that move heat from the star's core to its surface. These cells make the star's surface rise and move, which helps explain why its brightness changes over time. Even though this event has been forecasted by simulations, it has now been seen in unprecedented detail, giving us a better understanding of what might happen before a supernova. Also, experts are keeping a close eye on the star to see if there are any signs of a neutrino burst, which would definitely happen before the supernova. Even though no such burst has been found yet, the tools and methods for observing are advancing rapidly, and astronomers are optimistic about what they might find in the near future.